This presentation will introduce you to access control lists, often abbreviated as ACLs. We will discuss their implementation in operating systems and how they are used to enforce protection policies. Access control lists, or ACLs, are a security mechanism used to implement protection policies in operating systems. They essentially specify which users or system processes are granted access to specific objects, such as files or directories. ACLs define what operations like reading, writing, or executing are allowed on these objects. This provides fine-grained control over resource access, ensuring that only authorized users can perform specific actions on sensitive data. An access control list consists of entries, also known as ACEs, which specify the access rights for each subject, such as a user or a group. Here is a basic access control list entry structure. It includes a subject identifier, which is the user or group identification. The permission set specifies what actions the subject can perform, such as read, write, and execute. Inheritance flags determine how permissions propagate to child objects like subdirectories. Additional flags allow for special conditions or exceptions to be set. Each object in the system has an associated access control list that defines who can access it and how. Let's look at a simplified access control list implementation. First, we define an access control list entry structure. It consists of a subject ID and permissions, stored as bit flags. For example, read equals 4, write equals 2, and execute equals 1. Then we define an access control list structure. It contains the number of entries and an array of access control list entries. Access control lists are typically implemented as linked lists or arrays of entries. Each entry maps a subject, such as a user or group, to a set of permissions. These permissions are often stored as bit flags for efficient storage and checking. Access control lists are attached to objects in the file system metadata, allowing the system to quickly retrieve and enforce access rights. Now, let's discuss the access control list permission checking algorithm with some sample code. This algorithm checks if a subject has the requested permission to access an object. The function takes an access control list, a subject ID, and the requested permission as input. It iterates through each entry in the access control list. If the subject ID in the entry matches the provided subject ID, it checks if the entry's permissions include the requested permission. If the requested permission is granted, the function returns true, otherwise it returns false. If no matching entry is found, the function returns false, denying access by default. Like any security mechanism, access control lists have their own set of advantages and disadvantages. The advantages are fine-grained control. Permissions can be set for individual users on specific objects. Flexibility is another advantage, where different permissions for different users on the same resource. Inheritance, where permissions can propagate to child objects from directories to files. Explicit deny, which allows you to explicitly deny access to specific users. Now let's discuss some of the disadvantages. Management complexity, where as systems grow, access control lists become difficult to maintain. Performance overhead, where checking permissions requires traversing the access control list. Storage requirements, since each object needs its own access control list structure. Consistency challenges, since it is difficult to ensure consistent permissions across systems. To effectively use access control lists, it's important to follow some best practices. Follow the principle of least privilege by granting only the necessary permissions. Use groups instead of individual user entries whenever possible. Regularly audit and review access control list configurations to ensure they are up to date and accurate. Implement inheritance carefully to avoid unintended access. Consider using role-based access control for complex environments. Document your access control list design and permission strategy. In summary, access control lists provide a flexible mechanism for implementing protection policies in operating systems. They allow fine-grained control over who can access resources and what operations they can perform. While access control lists offer significant advantages in terms of security granularity, they come with management complexity that increases with system size. Modern operating systems implement access control lists with varying approaches, but all serve the fundamental purpose of enforcing access control policies. Thank you. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.